Okay, crew, we are down on profits and the future of Need a Cat looks bleak.
What do you think we should do?
Well, we need to find our demographic.
You mean lonely, middle-aged bachelors looking for the perfect fuzzy companion that won't walk out on them when they gain 15 pounds?
Maybe? Let's work through it. My money's on all cat ladies. So here we see a display of the age demographic of cat-owning men on a normal curve.
There's nothing normal about a 50-year-old cat-owning man.
What this normal curve shows is that the mean age of cat-owning men is around 50 years old.
So I was right. There's no better midlife crisis than buying a cat.
Partially, but let's take a look. The standard deviation of our data is 10 years. This means that 68% of cat-owning men are between 40 and 60 years old, 10 years on either side of the mean.
But that's 20 years we have to market to. There's a huge difference between a 40-year-old man who has everything to live for and a 60-year-old man who is on his deathbed and probably says goodbye to his wife in the mornings. How do we market to both groups?
Exactly what I was thinking. The data is too spread out. Let's take a look at women instead.
Wow, this is like something I've never seen before.
Yeah, so where I started is we had to find the class width.
From what? What did we do?
Okay,
Where
so
are those numbers?
we randomly selected 100 people, 100 women throughout the country, and surveyed them and this is what we gathered, our data on how many women have cats and their ages.
Okay.
And so we started with the class width, and we decided to settle with 7 classes because it worked out.
Okay.
And so the way you calculate the class width is you take the maximum value minus the minimum value over the number of classes.
So the maximum value would be the highest
The highest age
Okay.
and the lowest age over the number of classes.
Okay.
And so that was 90 years old minus 21 years old over 7 classes, and that approximated to 10 years. You always round up.
Okay.
And so then with that, we started with the lowest age, 21, and we added 10 years 7 times to create 7 lower class limits.
But there's a gap between classes here. Is that normal?
Yeah, that's normal. This is how class limits works, is that you only, is that there is always a gap between them of 1 unit.
So which class limit is this?
So this is the first, and
That's the lower class
this
limit?
is the lower,
Oh,
this is the lower class limit, and then the second number is the upper class
Okay.
limit. And so there are 7 classes, and in each class we recorded the frequency for how many women with cats fell into that age class, and then we also calculated the cumulative frequency, which is when which is that class and plus the frequencies from all the classes below that.
Okay.
So, for example, the 1, 2, 3, 4, the 5th class has a cumulative frequency of 33 because that is 17 plus 5 plus 5 plus 4 plus 2.
Okay. So our overall is 100, which
because-
makes sense because we surveyed 100 people. Okay.
Exactly. And so then what we did is then we found the class boundaries, because you mentioned earlier there's a gap between each class.
Okay.
And so this closes that gap by extending the class limits in each direction by half a unit.
How is that useful?
Well, it allows you to make sure that no data point would not be included
Oh,
in
okay.
this graph. And so we just copied it over here to this with the class boundary table, and it has the same frequency. And as you can see, we extended it in 0.5 in each direction. And it actually doesn't change the class width, as you can see.
Wow.
It still adds 10 each time.
Okay.
And so then, using these class boundaries, you can construct a histogram, which is what we have here. And so this shows that for each interval of 10 units on the x-axis, you can it looks kind of like a bar graph.
Okay.
And so each bar is 1 class, and the frequency is on the y-axis. So you can see the last class has 39 people who fell into that class, which lines up. And through this, we can now see that the majority of our female demographic is all the way down at the 80.5 to 90.5 class boundary.
So old cat ladies.
Old cat ladies. I was right.
Yeah.
I win.
Okay.
Okay. There you go.
So Max, I've seen you're hard at work with
Yes.
something else.
So this is an ogive, and what this is it's like the histogram where the x-axis is the age and the y-axis is the frequency, but this time instead of a normal frequency, it's the cumulative frequency that we calculated earlier. This is why we calculated that. The x-axis is the data point for the upper class limit, which is on this side, and so as you can see, as the x-axis increases, this goes up more and more as each class limit is added on, and you can see it starts off very slow and then shoots up right at the end, which is exactly what we expected, and it shows that our data is very concentrated at the high end of our demographic, and that's where we need to focus.
Actually, thinking about this, we could actually calculate how much of, like, 75% of our consumers, like, what their age would be.
Exactly. There's a formula for that. So what you do is 75% is the 75th percentile, so you do 75 over 100, because that's out of the percentile, times our total cumulative frequency, which is 100, plus 1.
Okay.
And you end up with, as you can see, it's going to be around 75.
Oh, that's cool.
And
So
so
I guess
then,
we interviewed 100 people, that makes sense.
exactly. And so then you come over here and it goes, and you go at 75 and you draw a line over and you hit right there. And at this point, you then go down and you see that your 75th percentile is at around 97. And that's how our data represents it. Okay.
And
Yes.
so driving is very useful for a marketing tactic.
It is.
And we will make sure, I think, in the future to market to
That was lemon.
old cat ladies.